Now here, if we were to draw a number line just for this, I would say here's 0, here's 3, and here's -3. And if the absolute value, the distance from 0 of 5x plus 1, you can say it like that because absolute value does mean the distance from 0. So if you say the distance from 0 of 5x plus 1 is greater than 3, that means, well, it can't be at 3, but it's anything bigger. And it can't be at -3, but it's anything smaller because it's further away from 0. But that's for 5x plus 1. And I need to solve for x. So I do exactly the same thing. So for the first one, I just take off the absolute value. And for the second one, if I put a negative there, and then I take off the absolute value, it's still the same, right? Because if I were to, let me see if this helps. If I were to put an absolute value around them, well, I really have the same thing because first I'm going to evaluate 5x plus 1. Here it's going to be a positive number. Over here it's going to be a positive number. And over here it's going to be a negative number. But once I take the absolute value, it turns positive as well. So that's why we have it like that. And again, I know many of you learned not to do what I just told you to do, but to just automatically change it to flip the sign and make it -3. If you didn't learn that, that's okay. But I want to explain why that happens. So now I just solve these two equations, and I will have something that looks like this graph, only the numbers will be different. It'll still start somewhere and it'll go greater than or less than, but it won't have a middle interval. So again, let's begin by starting to solve this. So I'm going to subtract 1 from both sides. So I get 5x is greater than 2. Divide both sides by 5, and I get x is greater than 2/5. So that's one side. And then here, again, I'm going to subtract 1 from both sides. And that gives me 5x is less than -4. Divide both sides by 5, and I get x is less than -4/5. So these are my two starting places. Like here, up at the top, it was 3 and -3. But when we went through and solved for just x, it changes the graph. And the new graph would look like this. So let's make this 1. And let's make this -1 because those are both fractions. And so 2/5. So let's divide this into 5. 1, 2, 3, 4, 5. So now I have 5. 1, 2, 3. I've divided 0 to 1 between 0 and 1 into 5 segments. And I'll do the same thing because we have 5 in the denominator. 1, 2, 3, 4, 5. Okay. And I'm going to say, first I'm going to graph this one, and that's x is greater than 2/5. So here's 2/5. That's an open circle, and it's going to be greater. And then I have x is less than -4/5. So 1, 2, 3, 4. So I have an open circle here. Let me write down, this is 2/5, and this is -4/5. So I have an open circle there, but x is less than -4/5, so it's got to go in the negative direction. Notice how it still retains its shape. It just the values change from -3 and 3 to -4/5 and +2/5. And it's just because we solved the equation for x. Okay, and this, again, I'm saying, if I refer back to my first example, I'm saying that this inside here, this 5x plus 1, is more than 3 away from 0. Or if we talked about it in distance, we would say it's more than 3 away from wherever you're talking about. Like if we go back to the FAU example, I live more than 3 miles away. And then we have a few here. Let's look at each one of them separately. Now, when you solve absolute values, as you saw that when we solve them, we usually get two solutions, but we get a maximum of two solutions. We can have either 0, 1, or 2 solutions, depending on what the absolute value says. For example, here, if I take the absolute value for A, if I take the absolute value off, I get 3x minus 2 equals 0, right? But I don't have a plus or minus 0. So for this, there's only one solution. So all absolute value equations or inequalities have either 0, 1, or 2 solutions. Everything we've done so far has had 2 solutions, but this one is, for A, is only going to have 1 solution. Most of them have 2, by the way. Most have 2. This one has 1 because I don't have a plus or minus 0. So I just have 0. So again, I'm going to add 2 to both sides, and I get 3x equals 2. X equals 2/3 if I divide both sides by 3. And here I have just one solution. Okay, so there's my one solution. Now for B, I know that the absolute value of x plus 6 is going to be a positive number, right? Because it's always positive. That absolute value always makes it positive. Distance is always positive. So how can I have some absolute value equal a negative number? Well, I can't. So this one right here actually has no solution, because there's no number that when I put it in the absolute values is going to give me a -4. So you always have to be really conscious of what you're doing. Just don't start doing things, is what I'm trying to say. So here I have one solution. Here I have no solutions, and I don't know what I have for the last one. Let's see. So I take off my absolute value, and I get x plus 5 is less than or equal to 0. But again, if I have, well, first of all, let's think about what that says. So can the absolute value of 5 be less than 0? And if I was in class with you, I'd wait for someone to say something, but I'm not. So I'm going to give you the answer. Of course not, because anything less than 0 is negative, and the absolute value of 7x plus 5 cannot be negative. For this one right here, I can only use the one where it equals 0, because the less than has to be gone, right? Because that would be a negative number, and the absolute value cannot be a negative number. Okay, so again, this is only going to have one solution. It's when this is equal to 0. I subtract 5 from both sides. I get 7x equals -5. I divide both sides by 7, and I get x equals -5/7. So even though that's an inequality, I only have one solution again. There are not 2 solutions to this, and hopefully you understand my reasoning. Absolute value always gives you a positive number. So that's the end of today's lecture. And if you have any questions, please feel free to contact me. Thank you so much. Have a good day. Bye-bye.